Hello everyone, welcome back to our channel. Today we are going to solve an interesting backtracking problem that is there on LeetCode itself, and that is the problem of the day of today. The name of the problem is construct the lexicographically largest valid sequence. Okay, so let's see what the question says. We have been given an integer n and we have to find a sequence that satisfies all of the following. Okay, we are being assigned three conditions over here. So basically the integer 1 occurs once in the sequence, and each integer between 2 and n occurs twice in the sequence. For every integer I between 2 and n, the distance between the two occurrences of I is exactly I. Okay, so the distance between two numbers on the sequence a of I and a of j is the absolute difference of their indices, that is modulo of j minus I. Okay, so we have to return the lexicographically largest sequence, and it is guaranteed that under the given constraint there is always a solution. So let's understand the problem statement in a much simple manner. So what is the goal of the question is, let's start with like what is given in the problem statement. So we have been given an basically, first of all I will tell you what is the lexicographically valid sequence. Okay, so a sequence or a string is lexicographically valid if it follows lexicographical order rules similar to dictionary order. That is, if two sequences or words differ at same position or some position, the one with the greater value at that position is considered larger. Okay, so it is the same order used in dictionaries to arrange words alphabetically. Getting my point? So basically the question is quite straightforward now. If we need to construct an array of size 2n minus 1 that satisfies the following conditions. Okay, the number 1 appears once in the sequence. Every number from 2 to n appears exactly twice, and for any number I, the second occurrence must be exactly I positions apart from the first occurrence. Don't worry, I will tell you with the example also. So, and the fourth condition is basically the sequence must be lexicographically largest possible. Lexicographically largest means we prefer larger numbers appearing earlier in the array. Okay, so for example, in this array, that is 3 1 2 3 2 is larger than 2 3 2 1 3 because we prefer the larger numbers appearing earlier in the array. So let's go through the given example. That is, input we have assigned as n is equals to 3 and output we are getting as 3 1 2 3 2. Okay, so basically what it is going on here is we have to place numbers from 3 to 1 in an array of size 5, that is 2 into 3 minus 1, 2n minus 1. Okay, and the largest number 3 should be placed first, with the second 3 exactly 3 positions apart. So what I am trying to tell you all is, if the 3 is at index 0, then the second 3 should be at index 3. Okay, this will make 3 positions apart. Then 2 should be placed next, that is ensuring that the second 2 is exactly 2 positions apart. Suppose 2 is at index 2, then the next 2 should be at index 4. Okay, so finally 1 can be placed in the remaining position. So we are after doing this operations, so we are getting with this final array 3 1 2 3 2, and this is our required answer. So what is the very naive way to think of the approach? Basically, how we can think of this approach is, first of all we have to think about the brute force. So what's the first thinking of you all, like how we can think? So it's very obvious, like we will generate all the possible permutations of length 2n minus 1, and we will check if the sequence satisfies all the conditions given in the question, that is distance and the uniqueness. Okay, and after doing this too, we will return the lexicographically largest valid sequence. Yes, and but in this question the problem is basically the efficiency part, because generating all possible permutation will get us into a very high complexity like exponential time. So why is this approach inefficient? Basically, the number of permutations is 2n minus 1 factorial, which is too slow. Okay, so it will take us around exponential time complexity and also space complexity for storing the permutations. That will be O of 2n minus 1, which will be also like a big deal. So this is basically impractical. So we need to think of a better approach, or we can say optimal approach. Okay, so let's move towards the optimal solution and how we can think of it. Let's build the intuition. Okay, so how we can think, like it's obvious in the starting itself. I told you all, like backtracking is the best strategy to solve this type of questions. It is basically similar to the n queens problem. Okay, so how we can plan our intuition, like basically instead of generating all the permutations, we should directly construct the lexicographically largest sequence using backtracking. So how we can implement this, like we should start with an empty array of size 2n minus 1, and we need to initialize with zeros. Okay, and then what we can do is basically we can place the numbers from n to 1, that is largest first, because we need the largest valid lexicographical sequence. Then for each number I, we need to find the first available position. Okay, and if I is greater than 1, we will check if we can place the second occurrence ith positions apart or not. That's the same thing I told you in the example itself. And if you don't understand this, don't worry, stay tuned, like I will tell you in the dry run also. So we will use the backtracking to explore all the possibilities, and once we get the valid sequence, and we will return that. Okay, so the approach is quite simple, and implementation, you are must be thinking like it will be too tough, like how we will generate all the permutation, or how we will basically construct the lexicographically largest sequence. So I will tell you through a table I made. Basically it contains, I will tell you with the dry run basically how this works. These are the steps, and these are the answer, array state, and actions taken also I will tell you on. So let's go through step 1. Basically we need to place n is equals to 3. So what we are doing is, so we try placing 3 at the earliest available index. Okay, and what should be the earliest possible index of an array? That will be 0th index. Okay, so since 3 must appear exactly 3 indices apart, we also place it at index is equals to 0 plus 3, that will be third. So if we place 3 at index 0, so the second 3 must be place it at index 3. This is the basically concept. And in step 2, next we try placing 2 at the first available index, that is index 2, and since 2 must be exactly 2 indices apart, we also place it at index 2 plus 2 is equals to 4. So you all can see basically the array state. In the first step, if we did at the 0th index, the 0th index 0th place got filled, and the third place also got filled. And similarly in the second step, at second position it is filled, and the fourth index position is also filled. So next thing is basically step 3. We will place 1. The only remaining number is 1, which appears once. We place 1 in the first available empty slot. We won't think much, like only 1 is left. We place 1 in the first available empty slot. Okay, and which is index 1 only. So in this way we will be able to construct the sequence like 3 1 2 3 2, and this way the lexicographical sequence and the largest one is basically constructed. And we also need to check the validity. We confirm that all the conditions are met, that is 1 should appear once, second should appear twice, exactly 2 indices apart, that is distance basically, and third should appear 3 should appear twice, that is exactly 3 indices apart. The sequence is basically the lexicographically largest because we placed 3 before 2 and 1. So this basically, let's come to the time and space complexity analysis of this question. So what we are doing is, let's go through, first of all we need to go through the code, then I will discuss this time and space complexity of this solution. So let's go through the LeetCode interface, how we are doing it. Let's understand it in a much better manner. So first of all, we have been given a like backtrack function to construct the sequence. Basically, we are passing index and vector in a answer to store our answer, and one bool is also there, and we are using n for the size. Okay, so first of all, we are doing it with the help of recursion. So it is obvious, like we need to return uh, we need to start with a base case in order to exit. So base case should be like, if we reach the end of the array, we should return true, that is valid sequence found. So it's very simple, like if index equal to answer dot size, we will straight away return true. And if the current index is already filled, we will move to the next index. Okay, the condition will be like, if answer of index not equal to 0, it's obvious that it is filled. So we will return backtrack index plus 1 and answer used and n. That is all the parameters we declared here in order to move next. So in the next part, like how we will try placing the numbers from n down to 1. Why we are doing n down to 1? Because we need the largest lexicographical order. Then we will iterate it over like we will iterate it over the array, and if the number is already used, we will skip that, and how we will skip it using the continue statement, and then we will initiate one variable that will be the second index, and if the num is equals to 1, it only appears once, so place it at the same index that is left. Okay, so basically for 1 only we initiated the second index. Basically the left position will be for 1. Okay, otherwise place num at the both index and the index plus num. Okay, so basically after that we need to check if we can place num at index and the second index without a conflict. So for this condition will be like, the second index should be less than answer dot size, and then answer dot index is equal to 0. Basically answer index is equal to num, and answer second index is equal to num, and used num is equal to true for placing the num at the both positions. And then after that we need to recursively try to fill the remaining array. Like after placing all the condition, we must be left with the some elements, 1 or 2 elements. So how we will fill it? With the help of recursive function, that will be like backtrack index plus 1. This is the function in the starting we use, and answer used and all the same parameters are there, and if the valid sequence is found, then return true. Then we will reset the changes if the placement didn't lead to a solution. That will be index answer of index should be 0, answer of second index should be 0, and used num should be false. So let's talk about the time and space complexity for this solution. Basically what we are doing, that is the function tries all the possibilities recursively in a backtracking manner. Okay, and the time complexity should be O of n factorial, since we try permutations only when valid. Okay, so space complexity should be like, we are using additional array that will be O of n for the used array, and O of 2n minus 1 that will be equivalent to O of n for the answer array. So this approach is quite optimal, and hope so you understood the solution. Please go through the code. If you have any doubts, any inputs, or any comments you want to put, I will be more happy to answer. Please like, share and subscribe. Thank you.